Seems like every couple years you hear about a plan to weaken hurricanes. The latest came earlier this month, to deploy a fleet of barges ahead of a hurricane to pump colder water from deep below to the ocean surface in the path of the storm. Now, it made news mostly because someone well-known, Bill Gates of Microsoft fame, made the pitch. And certainly hurricanes draw energy from warm water, so cooling the ocean ahead of a hurricane has been suggested before. I even remember a proposed tow icebergs from the Arctic to the tropics scheme to accomplish this. But all these plans face an enormous problem of scale. You would have to cool a huge expanse of ocean to have any noticeable effect. Let's do a quick calculation. Now, the key part of a hurricane for transferring energy from the water to the air is under or near the eye wall, the donut of heavy thunderstorms that surrounds the eye. Now, let's say the eye wall is 40 miles across, which is reasonable. That's an area of about 1,200 square miles right there. Now, if the hurricane is moving, say, 10 miles per hour, this critical area would sweep over an additional 8,000 more square miles in just a day. And now we're talking an area roughly the size of New Jersey. And that's assuming a perfect forecast of the track. The average air at 24 hours is about 70 miles, which means you'd have to increase the area to cool by another 12,000 square miles to be safe, giving us now a total area about half the size of the state of Pennsylvania. But let's say, just for sake of argument, that with enough money, you can do it. Water temperature is just one factor that controls hurricane intensity, and often it's not the most important. Certainly there are times when hurricanes intensify rapidly over very warm water. Katrina is a good recent example. But it's not hard to find cases of rapid intensification over water that's marginal in temperature. And here's an example from August of 2007 when Hurricane Dean rapidly strengthened in the eastern Caribbean. Here's Cuba, Hispaniola, and Puerto Rico. This chart shows what's called heat potential. Basically, it's a measure of the energy in the upper part of the ocean. Orange and red here indicate lots of heat energy, while green and blue relatively little. Now, when Dean moved across this area, its pressure dropped from 976 to 930 millibars in just 24 hours. Its winds went from 85 to 130 knots. That's Category 2 to Category 4, all the while over water that just wasn't ideal for intensification. The bottom line, other characteristics of the atmosphere in and around tropical cyclones are very important, including the amount of wind shear and the moisture content. Now, don't get me wrong, I'm all for trying to prevent hurricane catastrophes. The question is whether the damage you prevent is worth the money needed to develop so massive a project. You see, Gates isn't offering to pay for it. Fred is back with the extended forecast. Next.
3:08 again.
All right. Well, that was better. The time may be the same, but